All right, let's take a look at another set of problems that are kind of moving in that backwards vein of what we've been sort of doing. So, factoring special products again, and special products are, things like difference of squares, perfect trinomials, things like that. So, now we're going to talk about the perfect square trinomials, and I have the general form listed under here. And these are the two things where you can look at it and whatever A is and whatever B is, I know that if the square root of each of those, I multiply them by each other, and then I double that, and that's what my middle term is. And I think when we go through a few of these, we'll be able to make sense of it. And so basically, this one would give you A plus B squared, and this one would give you A minus B squared. All right, so we'll look at a couple of these, and hopefully it'll start to come back to you. I mean, it hasn't been that long since we've done these, but start to come back to you, and we will figure out how to factor these. All right, so here's a couple of examples of perfect square trinomials. All right, and so if you look at these, try to remember what we were dealing with was something where we had x. You take this. And then you square this, take the square root of this, and you take the square root of that. And if it is a perfect square trinomial, right, square root of 16 is 4, all I got to figure out is what my sign is here. Well, if this is positive right here, that means that this has no choice but to be positive. And then just think about it, check it. Well, if I've got, because this expands to x plus 4 times x plus 4, right? So that gives me my x squared right there. That's good. 4x and 4x, when you add those up, are going to give you your 8x. And then 4 times 4 is going to give you your 16. So that looks good, right? That's what we want. Now, let's take a look at this other one. This is a slightly more complicated version of it, and what you're probably going to see more often. So again, if it's a perfect square trinomial, you should be able to take the square root of your first and your last term, all right? So we got 2x and we got 3, and you should be able to multiply those two. So we'll go 2x times 3 and get 6x, and then double that. And that should be your middle term. And if you look at this, 2 times 6x is 12x, and indeed it is my middle term. The only thing I would have to do differently with this one is when I write it out and I do 2x, 3, and we'll square it would be minus. Because remember, it has to match this sign. So a real quick cheater way of thinking about that is if you have a perfect square trinomial, and this is, I have such a hard time saying that, and this is a negative sign, that means that this sign right here, when you factor, it's going to be negative. If it's positive, that means this sign is going to be positive. So it's kind of a little cheat you can use to kind of remember that. All right, let's look at some of these. Determine whether each trinomial is a perfect square trinomial. If it is, factor it. All right, so let's take the square root of both of these. All right, so square root of 9x squared is 3x. And then I kind of wrote this wrong. I'm thinking about this as I'm doing it. It should be square root of positive 4, because you want to make sure that term's positive. All right, so square root of positive 4 is 2. All right, so what I should be able to do is I should be able to multiply these together, right? And that gives me 6x. And then I should be able to double it. And that should be my middle term right there. Well, this gives me 12x, and my middle term is negative 6x. So this is no. It is not a perfect square trinomial. Because if it were, that would say minus 12x. Okay, so it doesn't. So it's not. All right, let's look at this one. 9y squared plus 24y plus 16. Well, let's take the square root. Both. So you get 3y, and then the square root of 16 is 4. And then multiply these together. Sorry, I shouldn't use that sign. I should know better. All right, so multiply those two together, and you get 12y. And then double it, and then you get 24y. And indeed, that's what we have. So we do have a perfect square trinomial here, which means we would factor it using these square roots, that I took, and then put that right there like that. And that is how that breaks down. Okay? And it's positive because this was positive. All right, let's look at another one. 2a squared plus 10a plus 25. Okay, so it's tempting, right? It's really tempting, but there's a big problem here. And the problem is this right here. In order for this, I got to be able to take the square root of the variable and the coefficient. I can't, and it should give me a rational number. In other words, not a square root. It should give me a perfect a number that you can square it and gives me a clean square root. And I don't have that, right? Because that's going to give me the square root of 2, and we don't want to deal with that. So this is not a perfect square trinomial. However, if it was a squared plus 10a plus 25, it would be, because then you would just say, okay, well, the square root of a squared is a, square root of 25 is 5, and you say, well, a plus 5, or a times 5 is 5a, and then you would double that, and that gives me 10a, which is what we do have right here, and so that would work out to be that. But as it stands right here, this is not a perfect square trinomial. So these are just kind of a few of the examples that you're going to run across when you're doing problems like this. So you always basically start by taking the square root of your first term and your last term. You multiply those together, and then you double it. And if that's what your middle term is, you're in good shape. Okay.